Hello everyone, this is Ben and welcome to this video tutorial on division and the greatest common divisor. So first thing we're going to do is start out in this video is talk about division, and we'll just review just how to divide. And this is something you may be currently learning in school, or maybe you've been out of school for a while, but you probably remember how to do division. Most people do, but it's always a good topic to review. It's very important. And let's just say we wanted to do, 2 goes into, let's say, 9. So to go over some terms here, the number 2 is called your divisor, and that's the number you're dividing by, and the number 9 is the dividend, so that's usually the larger number. It goes inside the division box. And so we can say 2 goes into 9 how many times? So you think about your times tables, and so 2 times 4 is 8, so it goes in 4 times. 4 times 2, you multiply to give you 8, and then we subtract, so we get 9 minus 8 is 1. So this is the remainder, 1. And then 4, the number we get when we divided 2 into 9, which went 4 times, this is called the quotient. Okay. So what about if we did 3 into 15? So 3 does go into 15 evenly, that's 5 times. So 5 times 3 is 15. 15 minus 15 is 0. So we get a 0 remainder, and then our quotient is 5. And remember that with our divisor is 3, and our dividend is 15. So looking at these two examples, we can write, an equation to express this. We can say that the dividend, we can say that that's 9. That's equal to our divisor, which is 2, times the quotient, which is 4, plus 1. So dividend equals divisor times the quotient plus the remainder. And that's the formula that we have right here. So 2 times 4 is 8, plus 1 equals 9. And so that is true. And then for the other division that we did, 3 into 15, we can say the dividend 15 is equal to 3 divisor times the quotient's 5, plus the remainder is 0, but we don't really need to add that because 0 has no value, so it's just 15 equals 3 times 5. Okay, so you're probably thinking, well, what's the point? I know how to do division, this is something I learned a long time ago, or, it could be something that you're currently doing right now, which is okay, and gets you some good practice in school. So sometimes when we have two numbers, we want to find the largest number that can divide both of those two numbers. And that's called the greatest common divisor. But before we get into that, we're going to kind of go, using some variables here, a couple of definitions to help us get started. And so what we're going to do here is we'll say this is the letter D, and this will be a divisor. And then we have this vertical bar. And then we'll say this is some number n. So the way you can say this is that D divides N. So, and then the way you can express this is that N is, that number is equal to some integer k times D. So k is an integer. It's also important to note that D for the divisor can't be 0 because we can't divide it by 0, and n is some integer, so we'll say n is integer, also integer. Which can be 0. So for example, you can say that 4 divides 8 because the number 8 is equal to 4 times 2, right? So this number here, 8, we put here, and then the number 4 with D for the divisor, 4 goes here, and when we figure out 4 times what number is 8, that's 2. So that's the number, like the number k. Now on the other hand, 5, does that divide 7? Well, no, right? So we're going to put a slash through that to say that it does not divide 7. So that means 5 does not divide 7. And so we can see the reason that is because if we have 7 equals 5 times some number k, 5 times k, well, we can't think of an integer k such that 5 times that number, k, will give us 7. So that's why 5 does not divide 7. Also, it's important to note that the number 0 does not divide just any other number, whether it could be 0 or let's just say some number like 3, alright? Because 3 is equal to 0 times k, and no matter what value of k that we multiply by 0, we get 0, and that will not equal 3. So we know that that equation is not true. So that's why 0 can't divide, anything else. Not even itself. Okay. So we've talked about division a little bit. We talked about different parts of division, with the divisor, the quotient, the remainder, and of course the dividend. And we talked about the definition of divides right here. D divides N. And then we know that that's equal to N. It's equal to K times D. So we're going to use this definition again when we talk about the greatest common divisor. And we're going to clear the board here. And start talking about that right now. So greatest common divisor. And the greatest common divisor, we'll say, we abbreviate that as GCD, and then we'll say of two numbers, we'll call them A and B. And we assume that A and B are two different numbers, they're not equal to each other. And we say that that's equal to D. And that means that this value of D, the greatest common divisor, is the largest divisor that divides both A and B. So it's the largest divisor that divides both A and B. So that means that D will divide A. So in other words, A is equal to K times D for some integer K. And then D divides B. So that means that B is equal to, we'll use another integer, we'll just say M times D for some integer M. So this greatest common divisor has to divide both of those numbers, A and B, and it has to be the largest one. So let's see how this works in an example. And let's say we want to find the greatest common divisor of 16 and 24. So we're going to use kind of just a basic way of finding this. Of course, in our next video, we'll learn a more systematic way to find the GCD, and that is you could find it for any two numbers. But for right now, we're just going to use just a simple basic approach. And the way that we're going to do that is we're just going to look at the number 16 and list out all the divisors of 16. So we know that 1 divides 16, 2 does because it's even, divides 16, 3 doesn't, 4 divides 16, 5, 6, 7, but 8 divides 16. And I think we can probably all agree that the last divisor would be 16 itself. So 16 has the divisors 1, 2, 4, 8, and 16. The divisors for 24, we start with 1, 2 because it's even, 3 is a divisor, 4 is also a divisor, 5, no, 6, yes, 7, no, 8, yes, 9, 10, 11, let's see, 12, yes, 13, 14, 15, 16, 17, 18. Looks like up to 24. Right, so those are all the divisors of 24. 1, 2, 3, 4, 6, 8, 12, 24. Okay, so after we do that, we're just going to kind of go down the list, just kind of see which ones they have in common. And because we know that they both have to divide 16 and 24, the value for D, the greatest common divisor. So we know 1 can't be it, so we can cross that out because it's 2. Cross that out. We know there's a bigger one. So 3 and 4, let's see, 8. We do have an 8 here for both. Let's see, 12 and 16, 24. And also 4 they have in common. And then I think that's the only other one that both of those share in common. So it looks like the largest divisor that divides both 16 and 24 has to be 8. So that would be our greatest common divisor, is 8. Okay. So that's what we did. We just found all the divisors of 16, all the divisors of 24, list all those divisors, and then find the largest divisor that divides both 16 and 24, and found that to be 8. So let's try doing another one. GCD. So let's see here what we're going to do. We'll think of some bigger numbers to do for this next one. We'll have GCD of 32 and 200. So the GCD of 32 and 200. So for this one, what we can do is we'll write out the divisors for 32. So that's 1, 2, 4, and then we have 8, 16, and it looks like the other one would be 32. So those are the divisors of 32. And then for 200, we'll have 1, 2, 4. Let's see, 8 would be 1. It's like 10 would be 1. Let's see here. What would be the next one? Would be I think it'd be 20. Does that sound right? 20. And then $25 would be another one. So it looks like, we could keep on going here with the divisors of 200, but we need to find the largest one that they're both going to have in common. So we really don't need to find all of the divisors of 200. So we know that 100 and 200 are some other ones. So we could stop there basically, because 32 will stop at 32 there, and then this one goes all the way up to 200 for divisor. So when we see the ones we have in common, we got 1 and 1, we got 2 and 2, we got 4, 4, and then we both see they have an 8 and 8, and 16, 32. That doesn't have anything in common with the other divisors. So we can stop there. So it looks like we see that the GCD of 32 and 200 is also 8. So how about that? We got an answer for both. For both of those problems, we got the same answer of 8. Let's try one more. Maybe we'll do one that's GCD of, let's say, 19 and let's say 75. Okay, so 19 and 75, we're going to find the greatest common divisor of those two numbers. So we're going to list out the divisors for 19. And 19 is a prime number, so the only divisors are 1 and 19, so that's pretty easy. For 75, that's not a prime number, right? So the prime number is a number that's only divisible by 1 in itself. And it's any number that's 2 or greater, because 2 is the first prime number, and it's the only even prime number there is. So 75, we got 1, let's see, not 2, 3 works, 4, 5 works. Let's see, 15 works. And then you have 25. And it looks like 75 would be the other one. So those are the divisors for 75. As you could do what we did earlier, you could just go ahead and stop, because you see that 1 and 19 are only two divisors here. So you have 1 divisor 1 and 19, divisor 1 and 75. That's the only divisors that they have in common. And so you're going to get the greatest common divisor of 19 and 75 equals 1. So whenever you have two numbers, A and B, and you want to find the greatest common divisor, and you get 1, you can say that A and B are relatively prime, since their only common divisor that they have is 1. So that's the definition of relatively prime. Okay, so what we'll learn about in the next video is we'll learn some things about modular arithmetic. We'll learn a couple of algorithms like the division algorithm, and we'll learn about the Euclidean algorithm, and those actually are two algorithms are related to each other, and one is kind of an extension of the other. And we'll also learn how to solve this equation here, where we have ax plus by is equal to d, and d is the GCD of a and b. So we'll learn how to figure out the these integers here, x and y, that satisfy this equation. And this kind of equation is called a Divisor equation. So we'll definitely learn about that, how to find those integers x and y, and we'll even learn how to find a general solution to find all the possible values for x and y that satisfy that equation. So stay tuned for that video, and this has Ben. I want to thank you again for watching this video on division and the greatest common divisor, and we'll see you next time. Take care. Have a good day. Bye-bye.